Hello and welcome to Horizontal Scaling in Azure SQL Database. My name is David Postlethwaite. I'm a database administrator for a large financial services company on the south coast of England. I've been working as a DBA for the last 10 years and I currently manage both SQL and Oracle instances. Previous to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle, and way back in time I was a Windows and a NetWare administrator. I'm an occasional contributor to the blog on gethanellis.com, and if you wish to contact me, my details are on the screen. Now here's our problem. You've built a SQL database and you're so successful that it keeps growing. More people want access, the amount of data is growing, and the queries are taking longer and longer. It needs more power, otherwise it will be too slow and your customers might start looking elsewhere. What a great problem to have! But what can we do to fix it? Well, traditionally, when we need more power, we've just added more memory, or bigger disks, or extra CPU to our current server. Worst case, we've gone out and bought a bigger and more powerful server to replace our current one. It's what we've done for the last 40 years. It's easy to do, just plug in the new bits and off you go. There's little to go wrong, doesn't tend to cost too much for small changes, and it doesn't take too much effort. I suspect everyone here has done this in the past. But buying a bigger and faster server can eventually become quite expensive. And how big can you buy? There comes a point when simply buying a bigger and faster server becomes impractical or doesn't give the performance increase that you need. And running everything on one box, putting all your eggs in one basket, as we say, can become risky. And what if your customers are all over the world? Do you want them all coming back to one server in one location? Would it be better for them to write to a database near to where they are? An alternative to just buying bigger is what is known as horizontal scaling or scaling out. Here you buy several smaller servers and link them together, so even though your database is spread over several servers, it looks and acts like one database. And this has been a common solution in the NoSQL world for quite a long time. Buying several small servers is often cheaper than one massive server, and in theory there is no limit to how big you can expand it. Having lots of servers gives more resilience, and in theory you can upgrade or apply patches much more easily. But more servers means more license costs, more electrical power, more infrastructure, and is technically a lot more complex to set up and manage. In SQL we can try and do this using replication, but anyone who has used replication will know what fun that can be. In Azure we have similar problems. Azure SQL Database has some serious limitations. The maximum size for a standard database is only 1 terabyte, which isn't very big in this day and age, rising to 4 terabytes for premium. But a premium database for either DTU or vCPU is very, very expensive. If your transaction throughput is outgrowing your Azure database, or if you want to separate your data into different locations around the world, or if you need to isolate different customers into separate databases for compliance, performance or geopolitical reasons, but you still want to keep your data as one logical database for your own administration, then scaling out or horizontal scaling is the ideal way to achieve this. Now, the splitting of data across multiple databases is also known as sharding, and it is Microsoft's implementation of sharding in Azure SQL Database, which we're going to look at today. Now, before we delve too deep, let's have a look at some of the terminology linked to sharding. Each database vendor uses slightly different wording for certain terms, but these are the ones that are used by Microsoft. So sharding is defined as a technique to distribute large amounts of identically structured data across a number of independent databases. Now, the end users that use a shard are referred to as tenants, and they will be defined by a shard key, and each tenant will have a unique shard key value. Now, the databases that contain our tenants are called shards, and the shard key and hence each tenant will be linked to just one database or shard. Now, there will be a table called the shard map that keeps track of which shard key belongs to which shard. In Azure, this is held in its own database called the Shard Map Manager. All of the shards that belong to a shard map are called a shard set. Now, tables that are sharded, in other words, the tables that have data distributed across the shards based on their sharding key, are called sharded tables. Now, tables that are not sharded, tables that need to exist on each shard but don't need to be split, are called reference tables. And all the data associated with a single value of a sharding key on a shard is called a shardlet. For sharding in Azure, to read and write to our shards, we need an application that is built with the Azure Elastic Database client library. The client library is available for .NET and also for Java. Finally, there are two features within Azure which can also be used with sharded databases. These are not part of the client library, but can be used on normal Azure SQL databases as well as sharded databases. Firstly, we have Elastic Database Query. This is a bit like a link server. As you've probably found out, traditional link servers aren't available in Azure SQL Database. This allows you to run queries against another Azure SQL Database or Azure Data Warehouse. Secondly, we have Elastic Database Jobs. Now, this is a scheduler within Azure SQL Database that allows you to run native t-sql scripts against multiple databases in one go. So it's very handy for your scheduled admin tasks that need to run on each shard. When we come to split our data into our shards, we have two different ways we can do this. The simplest approach is to create a separate database for each tenant, and this is known as single tenant sharding. It provides complete isolation for each tenant, allowing easy backup and restore. You can also scale each tenant or take the database offline without affecting anyone else. With single tenant, each database is associated with only one shard key. The alternative to single tenant is to place multiple tenants together on the same shard, and this is called multi-tenant sharding. This is suitable for an application that manages large numbers of small tenants. In multi-tenant sharding, the rows in the sharded database tables must have the sharding key in them to distinguish between the different tenants. In single tenant sharding, because there is only one tenant on each shard, the rows don't necessarily have to have the sharding key. But in both cases, the application tier is responsible for routing a tenant's request to the appropriate database. Now, there are two modes for multi-tenant sharding. Firstly, we have list mapping, and here we assign specific IDs to a particular database. This gives you the ability to control how many tenants go on each database. And you would most likely use this when tenants vary a lot in size to ensure each shard has a similar workload. Secondly, we have range mapping, and here we assign a range of IDs to each database. This is generally used where each tenant is of a similar size. And naturally, we can add more shards as our business grows, or we can scale up a particular database to cope with the growth of one tenant. So we can have vertical scaling inside horizontal scaling. Now, once we've created our shards, we have two ways of querying the database. Firstly, data-dependent routing. And here we query just one tenant using the sharding key. So our client application, written using the Elastic Client Library, will pass the shard key of the tenant to which it wishes to read or write to the Shard Map Manager. Now, this has a table within it called the Global Shard Map. The Shard Map Manager will look up the appropriate database name in this shard map for the shard key that the client has sent, and will pass the database name back to the client application. The client app can now query the correct database. The shard database will have its own shard map called the local shard map, and the shard will double check that you are querying the correct shard and that the shard is online for that shard key. If all is well, the database will run the query and return the data to the client. If not, it will pass back an error. Now, the client API will cache the shard details received from the Shard Map Manager to avoid unwanted round trips on each request. And this is why the local shard map has to double check in case a shard has moved to a different database since the information was cached. Multi-shard querying, as the name suggests, queries multiple databases in one go, and this will most likely be used for administration purposes. The client application, again written using the Client Elastic library, will query the shard map manager to find the names of all the shards. It will then query each in turn and return the result set using the union all operator. Now, there will come a time when you need to move a tenant from one shard to another. Perhaps a tenant in a multi-tenant operation has become too big for its database and needs to be moved to a new shard. Or maybe you need to consolidate some of your shards, move some smaller tenants onto one shard. If you do move tenants, then obviously it's important that the shard map manager is updated with the change. You could move the data using t-sql and then use some PowerShell to update the shard map manually afterwards, but this will almost certainly cause issues and lost data. A better way is to use the SplitMerge service. This is an Azure web service that will manage the movement of the data, take the tenant offline while it's being moved, and update the shard maps. It requires another Azure SQL database called the SplitMerge database, which will hold the status of each shard as tenants are being moved so that the shard map manager knows if the tenant or shard is available. You can use code, either PowerShell or C# to do this, or you can manually type the information into the web page associated with the web service. The link to the screen gives basic information on how to build the SplitMerge service, but the instructions are slightly out of date in places because they use a command called makecert, which has been deprecated by Microsoft. Fortunately, I had access to Windows 7 machine that had makecert installed on it, so I was able to use these instructions without having to try and convert them into PowerShell commands. Now, it's essential that the shard map manager is accurate and kept up to date, otherwise data is going to end up in the wrong place. If the global shard map in the shard map manager and the local shard maps on each shard become out of sync, then you're going to have problems and you won't be able to get to the data in the shards. Keeping these two databases in line is essential to the safe running of a shard. If you delete or rename a shard, either by accident or on purpose, you're going to end up with an orphaned shard mapping. So the shard will either need to be removed from the global shard map or the shard keys pointed to the correct shard. If you use georeplication and a failover occurs, you will need to have mechanisms in place to update your application to point to the new location of the shard map manager. You'll need to update the shard mapping details of all the shards in your shard map if they failed over as well. If you restore an Azure SQL database, it will be restored with a different name. Again, the shard map manager will need to know the location of the restored shard. And if either a shard or the shard map manager is restored to an earlier point in time, then it will no longer be in sync with the other databases, and you'll need to fix that. In these cases, you're going to have mechanism tried and tested to recover quickly. Microsoft have helped by producing a C# class called the Recovery Manager, which is part of the Elastic Client Library, and this is a number of methods to help resolve your mapping issues. I haven't actually tried this, but if you're going to build a system, you'll need to build these into your administrative application. Now, this is what we're going to attempt. I have a table full of addresses from 21 different countries across Europe, which we want to split up. In our demo, we will place records for different countries into different shards, and we will use the country ID as the shard key. So shard ID 1 will just have the range 1 to 7, shard ID 2 will have a range 8 to 14, and shard ID 3 will have a range of 15 to 21. And this is our shard set. We'll also have a reference table. In our case, this is the countries table, which we will join with the addresses table to get the country name. Now, we could create a copy of this on each shard, but we will use Azure External Tables and Elastic Database queries to reference the table that exists on the Europe Addresses database. Now we're going to use t-sql and PowerShell to set up the shards, And we'll also have a C# application to query them for this demo. So I hope you're ready. You can download a zip file of all the code from gethitandellis.com, and I'll give you the address at the end. Right, here we go. Here I am in SQL Server Management Studio. I've connected to my Azure SQL Server called Shard Pool Server. And over here we have the European Addresses Database that we want to split across our shards called shard DB1, DB2 and DB3. Now the data for the European addresses is taken from Kaggle.com. Kaggle is a great site for large real-world data sets, for development or testing, or even for using in your presentations. The data set actually has 80 million rows in it. I've only taken 1.9 million. I don't need 80 million rows. This is only a demo after all. In our database we have two tables. We have the addresses table, which will be the sharded table on each of the shards, and we have the countries table, which will be our reference table. Now if we take a quick look at our addresses table, you'll see I've only used a few of the columns in the original data set, just enough to make it look realistic. But here is our country ID, which is going to be our shard key. And our countries table, here we have all the countries from country ID 1, which is Austria, down to 21, which is Sweden. And if I run this query which joins the two together, you can see that I have got approximately 100,000 rows from each country, except for those that had less in the original data source. Let's move on to my next query window and let's start setting up the shards. These are the steps that we need to follow today. So we need to create a blank database for the Shard Map Manager, which I've already created, called the Shard Manager DB, and we need to create blank databases for each shard, which I've already done, called Shard DB1, Shard DB2 and Shard DB3. Now we need to create two users. We're going to create a user called Shard Manager, and this will have DB owner permissions on each database, and this will be used to create and manage the shard maps. We're going to create a second user, which I'm going to call Elastic User, and that will have read-write permissions on each shard, and that will be used to read and write to the addresses tables on each shard. We actually have to create the addresses table manually, and then we'll use PowerShell to create the Shard Map Manager and the local shard maps, and also to copy the data from European addresses to the appropriate shard. We'll also set up an Elastic Query to allow each shard to reference the countries table on the European database. We'll then have a look at the code in our C# application and run it, run some queries against our shards, and then we'll give the SplitMerge service a try as well. So I've already created the logins on our Azure SQL Server. So the first thing I want to do is create the Shard Manager user on the Shard Manager DB. I'll then change to Shard DB1. So I'm sure you're aware you can't use the use command in Azure SQL Database, so you have to type the name into the box up there. Right, so I'm now going to create the Shard Manager user on Shard DB1, and I'll also create the Elastic user on Shard DB1 and give it read and write permissions. Obviously, if you'd created stored procedures on your shards, you'd also need to give it executor permissions, but for this demo we're just doing standard read and writes, so that's fine. We'll now create the addresses table, which is just a copy of the addresses table on my European addresses database, and I'll add an index as well to keep it all happy. There we go. Now we want to create our external table on each shard for the reference table countries. I've already created the user, Elastic user, on European addresses, and I've given it read permissions. What we need to do now on our shard tables is create a master key and create a database scoped credential, which I'm calling Elastic DB credential, which is going to have the username and password of our Elastic user in it. So let's run that in. Now we need to create an external data source, which I'm going to call Europe Countries. The location is going to be my shard pool server, and the database name obviously is European addresses, and I'm going to use the credential that I created up here. But notice there's a trailing comma at the end. I have no idea why it's there, but that is needed, otherwise this command doesn't work. There we go. Now we can create our external table. So I'm going to use the create external table command. I'm going to call it countries and just put in the two fields, which matches the two fields in the countries table in European addresses. There we go. So if I now come over to ShardDB1 and I look at tables and I go to external tables, you'll see I have one called dbo.countries. I click on it, I don't get any options, and when I right click on it, you'll see that the list of options is much shorter. But if I run select star from countries on ShardDB1, that will link through and return the data which is in the countries table on Europe addresses. Now I have done a video on my YouTube channel dedicated to Elastic Database Query if you want to find out more. So now we're going to populate the addresses table in each shard with the correct data using PowerShell. So let me come over to my PowerShell query, and this is it. Now the reason we're going to use PowerShell is because you can't use the insert into command across Azure SQL databases. It doesn't work. So we're going to simply use the PowerShell bulk insert command to copy the data. Here I'm going to copy the IDs 1 to 7 and I'm going to copy them to ShardDB1. So what we're going to do is create a SQL connection to my shard pool server to the European addresses database using my shard manager account, and then select all the addresses where the country ID equals the range. We're going to read that into a data reader, and then I'm going to use the bulk copy command to insert that data into ShardDB1. So again, we're going to make a connection to shard pool server to our ShardDB1 database, again using the shard manager, log in, and then use the SQL bulk copy and just simply read it in. Now we could do this from my PC, but that will result in all the data from the Azure tables being copied to my PC to go into my data reader and then copied back again when we place it into ShardDB1. So what I'm going to do is I'm going to run this on the Azure portal. Now, I don't know whether you have seen that there is something called PowerShell within the Azure portal, which allows us to run PowerShell queries. So let me select this, come over to my portal where I've already logged in, and up here we have a little icon that says PowerShell. If we click on this, and it's actually opened up a bash window, so we need to select bash and change it to PowerShell, and that will open up a PowerShell window. It takes a little while to get going, and there we are. We now have a PowerShell window. So if I right click and paste my code in, it will now start running that for us on the Azure server without having to copy any data down to my PC and back again. Now that's going to take 3 or 4 minutes, so I'm going to pause the video while that runs. And here we are 4 minutes later, and it finished copying the records into ShardDB1. If we come back to our Management Studio and we do a count for country ID 1 to 7, which should be the ones on ShardDB1, we get 700,000 rows back. And just to prove that we haven't got anything we shouldn't have on there, let's just run that, and they both come back with 0. If we wanted to, we could also run this joint one, and we can see that we have on ShardDB1 country ID 1 to 7 with 100,000 rows in each. So the next stage, we need to build our shard maps using PowerShell. So let's go back to my PowerShell window and select my second script. Now for this script, we need to download the Elastic client library, and for that we need to use NuGet. That will install the client library into the folder that you run the NuGet command from. You also need to get a hold of the shard management ps1 file, which you can get from GitHub, and place that in the same location as the DLL that's listed. Once you've done all that, we can then import our shard management.ps1. So first of all, we're going to create a shard map manager object using the new shard map manager commandlet, passing in the login name, the password, the SQL server, and the database where we wish to create the shard map manager. We'll then get a reference to that shard map manager using the get shard map manager commandlet. So let us run those two in. And there we go. We now have our shard map object. Next stage is to create the global shard map. This is the syntax for a list shard map, but we're actually using range shard map. So I'm going to use the new range shard map, a key type of integer. We're going to call the range shard map, and we're going to place it on our shard map manager object that we created up here. Once I've created it, I will then get a reference to it. Once we have a reference, we can now create our shard maps. So we're going to use the add shard commandlet, pass it our shard map reference, the SQL server where the shard maps are going to exist, and each shard map in turn. So if I run these, and then we'll get PowerShell to list back to us the shard maps that we've created. So let's run that. If I pull this up, we should then see the results. There we go, and it's returned the results for us. So we have shard DB1, shard DB2, and shard DB3. So the next thing we need to do is add the shard mappings. This is the syntax for the list mapping, but obviously we're using the range mapping. So here we go down here. So we're going to run the same command 3 times. So we're going to create a range mapping, a key type of integer with a range low and a range high, the shard map that we wish to put it on, and the SQL server that it's going to create that range map for us. So in this case, it's going to be shard DB1, shard DB2, and shard DB3. Let's run that, and then I will also return the shard mappings using the get mappings command. So let's see what that brings back. That wasn't too bad. So here we have the shard mappings, status of online. The data source you'll see is shard pool server, database, shard DB1, DB2, and DB3, and it shows you that the values is 1 to 7, 8 to 14, 15 to 21 as we wanted. Let's go back to Management Studio and let's show you what it has created. If I come down to the shard manager DB, if I look at the tables, if I do a refresh, you'll see it's created a number of tables in a schema called __ shard management, and there are quite a number of stored procedures as well that it has created to manage our shard map. On shard DB1, if I refresh our list, you'll now see that I have some tables to do with the local shard map, and again there are some stored procedures that it's created as well. Now to save time, I've already populated shard DB2 and shard DB3 with our addresses data, and we have populated our address databases on shard DB1, 2 and 3 as well. So we're now ready to start creating our C# application to actually run our queries against our shard map. So let's switch over to Visual Studio 2017 where I have my C# application. I actually have 2 projects for this. I have this one, which is a Windows form project. I also have a Windows command line project, but I decided that the form project was probably the easiest one to follow. This code is based on the Elastic Scale starter kit supplied by Microsoft, so I can't take all the credit for what I have written here. What I have done is tried to reduce the complexity of the code in the starter kit to try and make it easier to follow in a demonstration. You're going to need to download and install the Microsoft Azure Elastic Scale client using NuGet again, and in this case you can use the package manager console which is built into Visual Studio to download it. You'll then need to add a reference in your application to the client DLL. Now just to give you a quick look at what the form is going to look like. This is the form that we're going to be using. I have a button here that will show us the shard map. I've got another button which allows us to run a multi-shard query against our shard map manager. We can put the query in here and the results will appear here. We can run a query against a particular shard the query in here again, and we can run a query to insert data into a particular shard. The query text will be here, the output again will be here. Over here we have a drop-down list, which will be a list of all the countries in our countries table, and we can select one of these to be used by the select and the insert statement. So let's go back to our form and let's have a look at some of the code here. We'll be creating a shard map manager object, which is an object in the Elastic Client library. And we have 3 strings here. First of all, we just need a standard SQL connection string. And this connection string connects to the shard map manager using the shard manager login. We need to know what the name of our shard map is. If you remember, it's called range shard map. And we also need a very short connection string, which has just got the login name and the password in it. That will become clearer when we get to that bit of code. Now, first of all, we're going to create a table adapter of all the countries. And here are the 3 queries that we'll be using in our form. So the first thing we're going to do is get our shard map manager. So we're going to create our shard map object, and then we're going to use the try get SQL shard map manager command using that connection string. Shard map manager load policy, you can either have lazy or eager, and the output will be our shard map manager object. Now that we've connected to our shard map manager, we have that object in memory. We can now run the show shard map command. Each of my procedures here work in a similar way. I use the string builder object to capture the output from our queries, and then I just display that on the screen. So the first thing we're going to do, we're going to create a range shard map and then use the try get range shard map, passing in the shard map name and getting our shard map back again. From that, we can use the get shards to return all the shards in our shard map. We can then use this command, shard map.getMappings, to actually retrieve all the mappings from our shard. And then all I'm going to do is loop through each shard in turn, returning the key range in that shard. And if there aren't any, we'll just say no shards found. Now the multi-shard query works in a similar way. Again, we get our range shard map. We return the names of our shards. And then we're going to use something called a multi-shard connection to connect to our shard map manager. Then with our multi-shard connection, we're then going to loop through each shard in turn, running our multi-query against each shard, returning our results to the screen. Selecting data from one shard, we're going to pass in the query text and the country ID from our drop-down. Again, we're going to get our range shard map, and this time we're going to say shard map.openConnection for key, and we're going to pass in our shard key, and then that short connection string which just had the login name and password in it. And what happens here is that Shard Map Manager works out which shard it needs to connect to from this information, and will now run my query, adding the country ID, and then run the execute reader command, and then loop round through the rows that we've returned, displaying them on the screen. Finally, add address does something very similar. Again, we get our range shard map name, open the connection for the key, passing in the country ID and that short connection string. So the shard map manager again works out which shard we need to look at, and then we run our insert command, execute non-query, and display the results on the screen. And that's it. So let's start up our application and let's see how we get on. And here is my application. Now let's click on show shard map and see what happens. So that's going to run that code. It's queried the global shard map and told us that we have 3 shards, DB1, DB2, which have the key range 178 to 14, 15 to 21. So the multi-shard query, I'm just going to do the select count statement. So if we run that, that should now go and run that on all of my shards, returning the list. So here we can see the count, the ID and the country. And the query will also return the database name for us if we like as well. So we can see that these will run on shard DB1, these on DB2 and these on DB3. Our data dependent routing, here we're just going to select the top 10 rows from the country that I select. So let me select a country such as Denmark. Click Select Data, and that will return the top 10 rows from there. And you'll see we've also printed out the name of the server that it ran on, which shard we've selected it from, and the connection string that we've used. And you'll see there it's added some extra options in there for us. If we want to add a row into our shard, it's very easy. So I'm just going to run this one in. So I'm just going to run an insert statement, and the values are already populated in there. Again, we'll do it into Denmark. Click Insert, and it's not come back with an error. And again, it's told us which database it's in. If we come back to this query and I add this in, and postcode equals a postcode, and if we run that, actually I've run it twice now. So here is the 2 rows that we've inserted into our table. So you can see from here, nowhere in the code did we actually list our shards. It's the shard map manager which is working out which shard we need to write to. Right, let's see now if we can get the SplitMerge tool to work. So I've already built and configured the SplitMerge service, and it is running in my Azure subscription. So if I come over here and select Cloud Service Classic, here is my SplitMerge service. I need to select staging to see it. There are quite a lot of options here. The example SplitMerge service doesn't use any of these, but the information which is most useful is the site URL up here, and down in certificates we will need to know the thumbprint of our certificate. Now, when I built the SplitMerge service, it created 2 certificates for me, both issued to star.cloudapp.net. I have one in my personal certificate and also one in my trusted root store. Now if I go back to overview, we could run this from this link here. If we pick this link up, start a new tab, paste it in, change the HTTP to HTTPS and hit return, that will open up the web service. And here is the web page for our sample SplitMerge service. Now we could fill in the type of operation, the shard manager server name, database name, the login account, the shard map name, and the key that we want to split and where we want to split it. But we're going to do this using PowerShell because it's a bit easier to demonstrate. So here's my SplitMerge script. The first thing we're going to do is create our local shard map on ShardDB4, and for that we will run this set of instructions. I've already run this, so I'm not going to run it again. We also then need to create a schema info. Obviously when the SplitMerge service runs, it needs to know which tables need to be moved and what the column is that has the shard key in it. This set of code here will create a sharded table info, pass in the addresses table and list the country ID as the shard key. And again, I've already run that in, so I'm not going to run it again now. So now we can actually run the SplitMerge code. And here we need to load in the PowerShell module SplitMerge, which comes with the Elastic Client Library. We have a whole series of parameters that we need to put in, obviously the login name and the password, the shard map manager details, the shard map that we're going from and the shard map we're going to. Here's that service endpoint that we saw on the website, the shard map name, which is RangeMap, the shard key type, integer. Now this is a bit strange because we actually have 3 values here, and I haven't quite worked out why we have 3 values. But it would seem from the investigations that I've done that when you set the split value, this will move any sharding key equal to or greater than this to the destination server. I'm sure someone somewhere can explain why there are these 3 values. We also need the certificate thumbprint so that the tool knows which certificate on my PC it needs to be using. And now we can run the command. So we're just going to run the submit split request commandlet, passing all those values in, and then wait for some output. So let me highlight all this. There is rather a lot of it. Up to there. Click go, and now we just need to wait for the output. That took about 3 or 4 minutes to run, and we can see now that it says it's copied it all. It's moved the range 6 and 7 to the shard DB4, and if we run this get mappings command, we can see, if I pull this up a bit, the shard DB1 now has just 1 and 2 on it. Shard DB1 also has 2 and 6. Shard DB4 has 6 and 7. Shard DB2 still has 8 and 14, and Shard DB3 has 15 and 12. Now the reason that these have ended up split is because I've run this several times offline due to an issue I had. And the thing to note that when we do split, that the ID for the shard key 6 seems to appear listed on both shards, but actually when you run shard map queries using my application, you will find, even though it lists it as being on both shards, the shard map manager does return the data from the correct shard. Now the final feature that I want to have a quick look at is something called Elastic Job Agents. I have a YouTube video on this, how to create and configure Elastic Job Agents, but we can use Elastic Job Agents to run scheduled tasks against our Azure SQL databases. So if I click on Shard Pool Agent, you can see that I have been running jobs previously. If I click on my jobs, you can see that I have 2 jobs already created. One's a recurring job that will run every now and again, and this was a one-off job to run queries against shards. You can create jobs and then create target groups. I have one target group. Unfortunately, this is still in preview, so you can't actually see which databases and servers are actually in that target group. Currently, the only way to configure and manage Elastic Job Agents is via PowerShell. As I said, if you want to learn more about Elastic Job Agents, please watch my YouTube video on that. Finally, now you've heard all the good news, what are the problems inherent in sharding schemes, and not just Azure? Now your data is spread over several databases, there are several issues that are going to come to light. Firstly, you've got to use some pretty complex code to ensure you talk to the correct shard. We've gone beyond just a simple t-sql query to using .NET, C# and Java code. Get this wrong and you could end up with the data in the wrong place, seen by the wrong people, and then GDPR fun and games start. Of course, there's no easy way to stop people just writing straight to the shard and bypassing the shard map manager completely. Again, you can have data in the wrong shard, and again, GDPR issues. You could improve security on your shards by using row-level security, which was introduced in SQL Server 2016 and Azure SQL Database to filter which rows each tenant can access. Since the data is now in different databases, if you want to run a multi-shard query, you can't guarantee transactions completing across all the shards. You'll have to find other ways to ensure your transactions across all shards complete successfully. It's not really possible to perform joins across multiple shards due to performance problems, since data has to be compiled from multiple servers and the additional complexity of performing cross-server queries. Trying to enforce data integrity constraints across shards just isn't going to work. You're going to have to use your application code to achieve this, and probably have regular SQL jobs to clean up any missing references. All those extra round trips to the shard map manager could slow your application down, something you're going to have to test. And if you use geo-replication for high availability, you're going to need code to deal with that. And a corrupt shard or mapping will cause issues and possible downtime, so again you will need more code using the recovery manager to help with this. I think it's safe to say that sharding is not for the faint-hearted. So I hope you have found this useful and given you a good understanding into horizontal partitioning with Azure SQL Database. I've put the links on the screen to the Elastic Client Library and the Recovery Manager. All my source code for this will be available from gethanellis.com on the screen. Please let me know if you've found this useful. Please leave a comment on my YouTube channel. It's always good to know that I am helping the community. So thank you very much for listening.